lesson will deal with quadratic equations and inequalities in the Maths Syllabus. So firstly, the most basic thing you will be required to do with quadratic equations is factorize them. So if you're given a quadratic equation in standard form as shown here, you will simply, obviously there's an x in both brackets, you will be looking for two numbers when multiplied together give you your constant, and when added together give you your coefficient of your x. And then obviously you switch your signs. The x value that makes each bracket 0 will then be your answer. In a more complicated one, something like this, you will need to multiply it out to get it into its x squared coefficient before an x and a constant. Then you simply move all your terms to the left hand side to get a 0 on the right, and you factorize as done above to get your values. In some instances, they may give you sum of cubes, as shown here. In this case, you need to know that if it's an x cubed plus a y cubed, your sign is a plus. Then you'll have a bracket of the cube root of the two, so x plus y, cube root of x being x cubed being x, cube root of y cubed being y. You will take the cube roots, so x plus y. Then your next sign over here will be a negative and your last sign will be a positive. So it's always your sign that you've been given, then an opposite, and then it's always positive to end off. Then your first term in your bracket is the first value squared. Then it's minus the product of the two values, so x and y, and then plus your y squared. Same way for difference of cubes, you're going to be doing the same thing, except you'll be using the signs as shown here. So it's negative because you've been given a negative, opposite to the negative, so it's positive, and you always end with a positive. When you are given these involving fractions, you will need to get a common denominator, or the lowest common denominator as said here, and you will need to multiply it out to get it into a simpler form. So your LCD here would be x minus 3. Remember, you must state your restrictions that x cannot be 3 because your denominator cannot be 0. Multiply it out and you will come to get a normal form of the quadratic, x squared minus 4x plus 3. You then factorize that as we have done above, and you will get x equals 3 or x equals 1. However, you must always check your solutions and remember that you've stated a restriction here that x cannot be 3, so you must ignore this answer and you must state that x can only equal 1. In a case like this where you've got different denominators, you must state all of your restrictions. As seen here, it is easier to switch this around to get an x minus 2 and take out a negative, simply because then your LCD, you have x minus 2 and x minus 3. Multiply through by your LCDs and you get a simpler form of the quadratic. Factorize that as we have done above and you will get your two answers. Remember your restriction that x cannot equal 2, so x only equals 4. Then we move on to equations involving substitution. So where you get an example such as this one, if you were to times out your LCD, which is x squared minus 2x, you would be getting an x to the 4. This term times this term will give you an x to the 4. You know that in core maths at a matric level, you guys have not covered how to factorize something like that. So firstly, let's state our restrictions that x squared minus 2x can't be 0. So x can't be 0 and x can't be 2. Next, we will look at how do we do the substitution. So you need to take the values, or the x values, that are going to give you an x to the 4 and substitute them. So in this case, we're going to say x squared minus 2x, your LCD, is going to equal k. We are substituting x squared minus 2x for k. Now we say k because we've substituted that. So it's k equals 18 minus 45 over k. Now you times out by your LCD, which is k, and get a normal quadratic, being k squared minus 18k plus 45. Solve that, factorize, and you get k equals 15 or k equals 3. But we've said that k is x squared minus 2x. So now we simply solve this here and this part here, and we go x squared minus 2x equals 15, and x squared minus 2x equals 3. Solve that, and we get 4 answers. We need to check all of these answers to make sure that they are not falling into our restrictions, and because they don't, all answers are valid, and you come out with 4 answers to the equation. In cases where you are given a square root, such as this one, you are required to square both sides. You must manipulate the equation to get the root sign alone. So you must make sure that there's only one term on the left, and that is only the root sign as shown here. Then you can square both sides. So you go square of that would be x plus 6, and x squared is x squared. Then you have a simple quadratic which you can solve, and you must always check solutions when you do this method, because often you will get incorrect or restricted solutions and they may not work. Always sub these values back into here to check that it gives you the right answer, as shown here. When you're required to square root both sides, you need to manipulate to get square alone, the square bracket alone, as shown here. You can then square root both sides, but you must remember that you must take a positive and a negative of the number that you're square rooting. Then you must solve for the positive case, and you must solve for the negative case, and you will get 2 values, which you must then sub back into your first equation to check that they are valid. Then we move on to completing the square. Sometimes in a question they may ask you to solve an equation, a quadratic equation, using completing the square. In this case, we do it as follows. If we are given an equation like this, we keep our x's to one side and we keep our constants to the right. So all x values to the left and all constants to the right. Next, you are going to need a magic number. We refer to it as the magic number because this is what helps us complete the square. That magic number is b times a half all squared. In this case, it would be b. B is the coefficient of your x value, and which is 2, times a half squared, which comes out to be 1. Comes out to be 1. Then you add your square, this squared bracket, which is your magic number, you add the number to both sides. If you add this number to both sides, it does not change your equation at all, because adding to this side and adding to this side means that if you take this across, it is 0. Once we've added it to both sides as shown here, we can go x squared plus 2x, multiply this out, which is 1, equals 1 plus this, which is 1. So x squared plus 2x plus 1 equals 2. You must not now take this constant across. You must leave it here so that we can square root. This is now a perfect square. If you factorize this, it's factorized into x plus 1 times x plus 1, which is x plus 1 squared. We then square root this as we have done above in the square rooting equation. X plus 1, square root of that is x plus 1, equals plus or minus the root of 2. We then know that x equals negative 1 plus or minus root 2. Now, a very cool little trick for completing the square is you can check these on your calculator. Once you've done all the working as we've shown here, you can plug this into your calculator using the function mode and check that it gives you this. If you've done it correctly, it will give you the same answer, but you must show all of this working if they ask you to complete the square, otherwise it is incorrect. In a case such as this one, a more complicated one, you do it as follows. So when completing the square, the coefficient of your x squared must always be 1. Here the coefficient is 4, so we need to change that. So we divide through by 4 in order to get this to be 1. So we move our constant to the right as we did up in the last example. 4x squared minus 12x equals 7. Divide through by 4. X squared minus 3x, because 12 divided by 4 is 3, equals 7 over 4. We get our magic number the same way as we did above. The b value times a half squared, which is, this b value, 3 times a half squared, which is 9 over 4. We add that to both sides as seen here. This is now a perfect square, so we solve it into its perfect square, equals 4. We add these together, which is 4. Then we simply square root and square root that, remembering the plus and minus, and then we solve it individually to get our two answers. When asked to use the quadratic equation, you may be asked to specifically use the quadratic equation, or you may simply use it to check your answers. It is quite useful sometimes. So you must always, when you're given an equation, you must always write it in the standard form of ax squared plus bx plus c, so that you can sub all the values into the quadratic equation. Then you simply plug in your values into the equation and it will give you your two values. Remember, the first time you do it, you must do a positive. And the second time you do it, you must do a negative, and that will give you your two values. Now when we look at roots of quadratics, so delta, which is b squared minus 4ac, tells you a lot about the roots of your quadratic equation. If delta, which is b squared minus 4ac, which you can calculate for any quadratic equation using those values, if delta is greater than 0, the quadratic equation has two distinct roots. If delta equals 0, one real root is present, or two equal real roots. If delta is less than 0, the equation has non-real roots, which means that the quadratic equation graph would not cross the x-axis. And if delta equals if delta equals a perfect square, then roots are equal or non-equal roots. So that's shown in the diagram here. So if delta is less than 0, roots are non-real and you do not have to describe them further. You can simply say roots are non-real. However, if delta is greater than 0, you need to describe them further. If it's greater than 0, you know it's real. If delta is a non-perfect square, you know that your roots are irrational. If they are a perfect square, they are rational. If delta is equal to 0, then your roots are real, rational, and equal. And if delta is greater than 0, your roots are real, rational, and non-equal. That is very useful, as they'll sometimes ask you to describe the roots of an equation, and you must always go through each one of these. You mustn't simply say it's real or it's rational. You must always describe it in all forms. So as shown here, it says show that roots are rational. So we take it, b squared minus 4ac, delta comes out to be 32. Therefore, delta is greater than 0 and not a perfect square. Therefore, roots are real and rational and non-equal. Now we're asked to show that this equation has one real rational root of x equals minus 6. So we work out delta. Delta comes out to be 0. Therefore, the equation has one real root. If you were to solve it by subbing in minus 6 into this equation, you would realize that it will equal 0. Your left-hand side, as seen here, will equal 0, which indicates that it is a root. However, mathematically, it is more decisive to rather solve it using delta, as this will, in most cases, it will be asked in a way in which you will need to use delta. Moving on to simultaneous equations. You will be given two equations involving x and y, or two variables that are given. You need to manipulate them to get one of the variables to be equal to a certain equation. As seen here, we manipulate this equation to be y equals 2 minus 2x. We want y. We want to be able to sub this value in for y, wherever y is present in this equation. Once we have got this, we sub in the value for y into the second equation. We come out with x equals these two values. Once we've got these two values, we then sub it back into our first equation in which we solve for y. Now we're going to be solving for y using the x values. As seen here, we go y plus 2x equals 2. Now, where x is present, we sub in 2 over 3, and we get y equals 2 over 3. Where x is present in the second one, we sub a half, and we get y equals 1. You must always remember that there are two cases. You get two x values here, therefore you must sub both values in separately to get two y values. And remember that y equals 2 over 3 corresponds to x equals 2 over 3, and y equals 1 corresponds to x equals a half. Now we look at max and min problems. So with a quadratic equation, if your a value, which is your coefficient of the x squared term, is greater than 0, you will have a minimum value. If your a value is less than 0, you will have a maximum value. In order to find out what that minimum or maximum is, we use this equation negative b over 2a. Now in order to do that, as seen here, we go negative b over 2a, which is negative 4 over 2 times 2 is negative 1. So we have a minimum at negative 1. Because a here is greater than 0, we know we will have a minimum. And our turning point is now negative 1. So we know we have a negative at a minimum at negative 1. You can then sub in negative 1 into your equation to get your y value at your minimum, and this x value and this y value will then be the coordinates of your turning point of your quadratic graph. As seen here, it's the same thing, just a more complicated one. We multiply it all out, we get a simpler form of the quadratic. A is below 0, that means we're going to have a maximum. We use our formula, and our x value comes out at negative 1. Once we've solved for this x value, we now know that there's a max value at negative 1. We can plug the negative 1 into the equation, this equation over here, to solve for the y value, which comes out at 8. That means at negative 1, 8, our coordinate, we have a maximum turning point on the graph. Now we move on to inequalities. Here we have a simple form of an inequality. So the most basic way to do this is to get all your x terms on the left and all your y, constant terms on the right. And importantly, you must always remember, if you divide through by a negative, you must switch the sign of the inequality. So here we have a less than sign, whereas here we have a greater than. That is because we have divided through by a negative 1. Can you see it was a negative 8x less than 12? We divide through by negative 1 to go 8x is greater than negative 12. Then we simply solve it like we would an equation, and we get x is greater than negative 3 over 2. Here we have a quadratic inequality, which is more complicated. We must get all our terms to the left-hand side as shown here, factorize it into its factors as we learned earlier. Once you've got these factors, you've got your critical values that you will use on your timeline. Then, once you've got your critical values, you must draw up a number line as shown here, putting on your critical values that you've got here, which are your factors of your quadratic. Once you've done that, you must test for the signs. So you go left of negative 5, so anything smaller than negative 5. So let's use negative 6. if we plug negative 6 into this equation over here, we get it's positive. So we go negative 6 is 36, minus 3 times negative 6 is 18, so 36 plus 18 is 54, minus 40 is 14. Therefore, this is positive. Over here, we look for a number between negative 5 and 8. So let's use 0 simply because it's easier. 0 squared is 0, minus 3 times 0 is 0, minus 40 is negative. So we put a little negative sign. Number greater than 8, let's use 9. 9 squared is 81, minus 3 times 9 is 27. 81 minus 27 will give you 54, minus 40 is 14. Therefore, over here, we have a positive value, so we put a positive. However, we are looking for this equation less than or equal to 0. Therefore, we are looking for this interval, this negative interval. We ignore the positives because that's where it's greater than 0. So we go x is greater than negative 5 and less than 8, as shown here. However, you must watch out to see whether they've said equal to or not equal to. If it is equal to, you must include your two CVs because these two values will make the equation 0, which makes it equal to 0, and therefore you must put in your equal to. If it had just been less than 0, you would exclude these values and simply go x greater than negative 5 and x less than 8. Same case over here. We get our CVs by factorizing 5 and negative 5. Test for our cases, positive, negative, positive. We're looking for where it's greater than 0, so we'll take this case, x less than 5. Note that we don't include 5 because it's not equal to 0. Or x greater than 5, and we don't include 5 because it's greater than 0. Over here, we must ensure if you get a fraction where you have x in your denominator, you must not times through by x because you will lose one of your values. You must simply break it down as we can see here. Your x must be x minus 5 is less than 0 and x is less than 0, where x minus 5 is greater than 0, x must be greater than 0. And we solve it as we have before. However, we break it down into these two cases because we've got an equation up here and an equation down here. We can't times through because we would lose a value. We solve on the number line. We get our cases. We want it where it's greater than 0, so positive. So it's x less than 0. Do not include 0 because it cannot be in the 0 cannot be in the denominator. Or x greater than or equal to 5. We include 5 because 5 can be in the denominator and it equals 0, and they are asking us for where it is equal to or greater than 0.